Life science buildings have very specific requirements in terms of, floor vibration performance, mechanical systems, et cetera, that obviously not going to get into here. But it's a more demanding building type. So to design a timber structure in particular that meets the requirements of that more demanding building type is a real challenge. And so we had this idea for a system that we really felt would address these challenges.
Welcome to the ONEder Podcast. This is your host, CCB, and today's session is a conversation with one of our 2022 ONEder Grant teams. I'm excited to have a conversation today with Kenny Hung and Tom Parrish from DES. Tom, why don't you introduce yourself to us?
Hello, I'm Tom Parrish with DES Architects and Engineers. We're a multidisciplinary design firm on the peninsula, and I run the structural engineering group here. And so my role was I doodle a lot, and my role was kind of taking one of my engineering ideas and marrying it to a lot of Kenny's ideas on sustainability and seeing if we could find some real benefits. And then my role was kind of leading the structural engineering aspect of the research, in terms of making sure that what we were proposing really performs in a similar way to buildings that are currently being constructed out there.
So I am going to say for everyone who's listening, there's a research report where you're going to be able to look at all the drawings and understand more about the research. So if there's some question as we're having this conversation, know that you do have access to that. So Kenny, tell us a little bit more about your role.
Well, thank you, CCB and Tom. My name is Kenny Hung. I'm very excited to be here. And I'm a designer by training, and I'm always interested in combining design and sustainability into one approach, one process. So that's why I am here. I am currently leading the DES sustainability team. And for this project, I'm trying to put everybody together, get the teams together to look at ways that we can really looking at a different way to do life science building that have reduced the embodied carbon, really have a positive impact of the project. So that's what I'm doing, working with the team here.
That's fantastic. So when I look at your report, I see a large number of team members contributed to this particular project. So how about, Tom, if you would start and give us an overview of the topic title and explain all the members of the team that contributed.
Wow, I'm not even sure I know the complete topic title. Kenny, what is our complete topic title?
Well, our complete topic title is Reducing Embodied Carbon in Life Science Buildings through Mass Timber. That's our research thesis. And we have a really big team working on this. Tom, you want to talk about it?
Yeah, sure. Yeah. So again, I kind of had this concept that I thought could provide for a very stiff, high performance floor that would work really well in life science buildings. So on the structural side, I think we wanted to prove that, to validate that. So one of the big issues in life science is vibration performance. And that turned out to be a really big can of worms, trying to make sure that what we were proposing provided the same level of performance as steel and concrete buildings out there. So
I want to stop you for a minute and say DES does a lot of work with life science industry. And so you have accumulated knowledge and experience and expertise in what the requirements are. So when you say the floor vibrations, everybody might not understand why exactly that's so much.
Sure. Yeah, life science buildings have very specific requirements in terms of, floor vibration performance, mechanical systems, et cetera, that I, obviously not going to get into here. But it's a more demanding building type. So to design a timber structure in particular that meets the requirements of that more demanding building type is a real challenge. And so we had this idea for a system that we really felt would address these challenges. So my team, Amy Doman on my team in particular, really did a lot of work trying to understand floor performance, vibration performance, and all of those criteria, so we could make sure that what we were proposing is really going to be something that a developer or an end user will want to build, want to use, and be comfortable in.
And Kenny, the benefits that that construction methodology brings from a sustainability standpoint, you go into great detail in identifying what those are overall.
Right. I think, we are a team with working with women apparel, another sustainability leader in the office. So we're looking at, so with this exciting concept, this interesting idea of using mass timber, how can we validate the benefits over some of the conventional structural systems that we know of, like steel and concrete? We have looked at other research, other papers for other building types, like office buildings. There's a substantial reduction in terms of using mass timber as a structural material, which are lighter weight, that is a natural material that can store and sequester carbon, embodied carbon. So we are very interested in this idea, working with Tom, our architectural team, and life science team, to really try to take this concept and we're looking at different ideas and try to demonstrate through a hypothetical building design to show that all these things can really work, can have the curb appeal, can they have the equivalent performance. And obviously, we look at a lot of the analysis of the embodied carbon content, sort of the manufacturing process, the extraction process. One of the things we find out, compared with concrete as a baseline study, we know that using mass timber will substantially reduce the amount of embodied carbon in the range of 70%. That's a really an interesting finding.
And one of the things we also did on the structural side is so Kenny could really, and his team could really go do that quantitative analysis of the benefits. We created all of these baseline structures, using the exact same criteria, same base sizes and performance criteria. So we could really get an apples to apples comparison of what the benefits of this system are.
And again, I will say to all of our listeners, all of this is in the research report, and you can see the drawings and the details and the research that's related to it. One of the things that I thought was really lovely, because we end up taking nothing away from structural or architectural, but the experience inside the building of the user is something that's very important to the One Workplace team. And the thoughtfulness of how the mass timber incorporates into the experience and the biophilic design was extremely well articulated, I think. Can you want to talk about that a little bit?
Yeah. I think, like I said, we focus on all the aspects of trying to put this project together, looking at these things. And obviously, biophilic design, daylighting, really expressing the idea of using mass timber as interior materials as well, that again, save a lot of interior finishes. That's a one benefit. But the warmth and the materiality of mass timber in the life science, in an environment that we are trying to create life-saving medications, technology that help save life. That's important. And, for the scientists that work in there. So we did a lot span of time understanding, using mass timber, what are other benefits, such as, the biophilic design ideas, capturing daylight is important. So when we think about the design, we also want to think about how the inside really respond to the outside climate influences. So you can see in the research paper, we can demonstrate, hey, how this mass timber project really responds to all these different external factors and how that would impact create a healthier, better experience space for the scientists be there.
In the research paper, there are, as I say, all the drawings. And Tom, you must have been excited getting to show the prototypical building of your dreams.
Yeah, absolutely. I mean, I doodle a lot, so I have all of these ideas rattling around in my head. And I think to myself a lot, wow, this might have some real benefit, but I don't know what to do with it. So it was a real nice opportunity when, Kenny and I talk often about how we might do things better. And it was a real great opportunity when the ONEder Grant came up and Kenny and I kind of looked at each other and said, yeah, I think we could do something with this. So it's a really great opportunity to, just put some innovative ideas out there and see if they stick.
Yeah, exactly. I mean, particularly, like Tom said, we're excited because we know that the theme for 2022 ONEder Grant is about ESG. environmental, social, and governance. And that's really what we are trying to do here. Think of better way to do building types that we are familiar with, we have knowledge with, and how we can improve it. We can do it better. And that's the whole idea, exploring these different ideas and, sharing the ideas too. That's why we come up with this research topic. Mm-hmm.
So within DES architects and engineers, there have been a number of people involved in the project, and I'm sure a lot of people understand kind of what you've been up to. And where do you see this output going? Have there been any conversations with potential end users or building owners? Do you have those what ifs? Do you get the opportunity?
We've certainly thought about it. I mean, I think, when we talk about what our ultimate goal is here, it is really to, take an innovative idea, and when we talk to a client, or when any engineer talks to a client, be able to say, yes, we can do a timber building, and it's going to have the long bays you're used to. It's going to perform the way you're used to. It will give you everything and more that a steel or concrete building will get you. And yes, we think this is a right way to build a building. And to say that with confidence, because, right now, you don't see timber buildings out there because, they're typically shorter spans, huge beams, taller to floor heights. And, most developers and even end users are not really going to contemplate that, unless they're absolutely sure that they're going to get everything they can in a steel or concrete building. So I think, our goal is to get to the point where we can sit in front of a client and say, yes, we can give you a timber building that gives you everything you want, and say that with confidence.
I was going to ask the question, when you get into the specifics of life science buildings and what the requirements are, you get into that lab area, smaller or larger, depending on who the client is and what the activity is. And how do you manage the requirements inside the labs with the mass timber? Is there any additional requirements?
I'll talk and then hand off to Kenny. We did sit, David Hronick, who you see on our list of contributors, is one of our lab planners. And so we spent quite a bit of time going through what a lab setup might look like, what utilities are required, how they would be routed, how ducts would be routed, and really make sure that a real lab, life science lab, would work in this building and work well. And that did require some adjustment of the structural design. We ended up making, the beams narrower and deeper, and kind of still stay within that zone where it was really comparable to steel and concrete buildings. But there was a lot of meetings with other members of the team to really make sure that this really worked with a real building. And then it went on to Kenny and his team with the prototype.
Yeah, no, I think that's exactly what we have done. It's really thinking, how this mass timber concept is adaptable to different conditions in a real life science situation, the different type of labs. There's some lab that will require sort of a enclosed ceiling, that some of the lab could have a less restrictive requirement, that could have open ceiling, we can see the wood, the timber. So I think the whole idea we will demonstrate is, yes, it could be working with all different situation as much as we can try to show here. And I think that is a very integral part of the research exercise, that how the effectiveness of applying this concept to the life science use. Mm-hmm.
You guys have very deep experience and relationships with the life science community in the Bay Area for sure. And I wonder how accepting is that particular vertical market to innovation. One would think they would be, but on the other hand, there's so many restrictions. I just wonder, do you feel that a level of confidence that there's going to be interest in moving in this direction?
I think so. Again, so we're very familiar with what life science tenants are looking for in buildings and what life science developers are looking in buildings for curb appeal. So as long as we can show that we can provide the same open floor plans, same performance criteria, same flexibility with mechanical systems that a typical life science building would provide, I think the mass timber is only adding to the value.
Yeah. What does it do to cost?
We haven't really looked at cost in our research, but in terms of a typical mass timber approach, we're definitely saving material, floor to floor height. So it's definitely this kind of innovation, I think, moves mass timber, in the right direction. So.
Well, for one thing, we're using mass timber also as the interior material, the interior finishes that substantially save a lot of the cost, and the lighter weight too, like Tom suggests, would be helpful. I think too, thinking about mass timber application, life science, we know that, again, life science is in demand. Life science buildings and products are in demand across the country, and especially in the Bay Area. And while there's a strong demand for life science building projects, there's a stronger desire from both the users and also the developer side and the scientists, for more adaptive, more environmental friendly buildings, a life science building that really reduce all this impact or have a positive impact. So we see this is a great opportunity. This is sort of a direction and that people would like to see how it can be flourish and it can be going to something that impactful. Mm-hmm.
Yeah, I was going to drop some little tidbits there, but I knew you would be able to articulate it because we hear the same thing from our biotech life science clients, that they are committed to sustainability and better environmental impact and, better approach to living and working. So it would seem that this would be kind of a slam dunk, if you will, in a bad sports analogy, to say it just feels, I can hear the Genentech folks just kind of going, wow, that's very interesting. Was there anything surprising that you uncovered in your research? Anything that you were not considering, that you had not thought of? And there doesn't have to be, because you could have thought of everything.
No, I think what really kind of surprised us is sort of how little the body of knowledge is in terms of timber building and, how they work, how they perform, what the best way to build them is. It really is sort of in its infancy in many ways. So it was really kind of a surprise that we've been building with timber for thousands of years, but there's still so much we don't know about how these buildings really work. So it was kind of a surprise to me how much effort and research it really took to kind of understand how these things really worked.
I am on the same page with Tom. I think there's so much more to learn and explore and research, especially when we're on a real project. I mean, for example, thinking about getting into more sustainability aspects, creating a more better, adaptive, wellness thought out kind of life science building. There's so much more we can think about, research on. For example, like the facade materials, we know mass timber that could maybe have a faster construction schedule and all that can put together. But we are also thinking about not just the interior, but also exterior. What about facade material finishes that could be part of this mass time building package, if you will, so that we can think about this holistically. So I think there's so much more that we can explore with this mass timber life science building research, an opportunity.
The prototype, the image of the complete building from the exterior in the research is absolutely beautiful. And I was reminded of, and it's kind of interesting, I worked in a lot of European projects in a previous life, and the nature of daylighting and how the buildings are actually smaller in floor plate because they want to access everything. And it looks more similar to one of those type of buildings because it's so much kinder to the inhabitants with accessibility to natural light and to whatever the exterior environment is, which we know has positive impact, on people's well-being, but also on productivity. So it's a lovely, that's a silly word to use. The building itself is lovely, but the research is so in depth. It's really impressive. So I want to give you huge kudos. We've already talked about where you think this might go. Do you have any other thoughts on how you might share the information so that all the research that you did benefits larger quantities of? Will this be presented anywhere? Because it feels like it's one of those kind of research projects.
Certainly we're presenting it internally next week, for all of our architectural friends to think about that. And there are certainly others in the industry and clients that will show. But I think bigger, to me, it's really sort of this innovative approach. Not innovative is not the right word, integrated, thinking about building structure, thinking about building systems, and thinking about how they all work together when you're designing a building. To me, that's, if there's a message I want to get out there, is that that has real benefits. And that's really a necessary part of how we need to design buildings if we really want to achieve the kind of sustainability goals, we're after. I think that if there's a big message, that's the one I want out there.
I really think that this is really just a showcase how, integrate the design process that need to happen. Obviously, yes, we've been doing it, but it's really this integrated team that everybody get together to figure out this problem and how we can do it better. And we can showcase that we can virtually do it better. I think that's an important message that we're going to share with our client. We're always looking at things that, like as we mentioned at the beginning of the call, integrating design and sustainability, and takes everybody's effort and participation to do it.
Well, I'm going to say we're delighted with having given the ESG umbrella out as the topic theme for this year's, or for the 2022 ONEder Grants, because the thoughtfulness of each one of the grant awards it will make strides forward. Each one of the projects are making a huge contribution to the way that people are thinking and integrating, to both of your point, the nature of the sustainability, environmentally aware building from the very beginning. Let's stop and think about that. Let's incorporate that in a much more intentional way, so that people are bringing the nature of belonging and the nature of well-being so much more specifically forward. It's really lovely to see. So I'm going to say thank you again, Kenny and Tom from DES Architects and Engineers, for spending this time with us. For everyone listening, the ONEder Grant webpage will have an abstract, a single-page abstract. If you'd like to look at it, there's about a 30-page report that's got great, beautiful drawings. I'm going to say that. Great, beautiful drawings, and an enormous amount of the research information. And we will have a presentation at the end of March where each one of the teams is going to have a 5-minute opportunity to just kind of give the overview. And we are delighted that you have participated this year.
Well, thank you very much for the opportunity. Really appreciate it.
Well, thank you, Cecilia, and thank you. Really appreciate that.
It's been our pleasure, I have to say that. So thank you very much, and I'm going to sign off. Bye-bye.
Bye.